We are starting. Now, first of all, what I've realized, we still have a few issues to do with the matrix algebra. So I would want us to start with this question, which will be able to take us through the matrix algebra, the algebra of additions, algebra of okay, the algebra of okay. So for example, I would want to use this CASNEB question to show you how we do matrix multiplications, matrix multiplication, and inversion. Matrix multiplication and inversion. Inversion. Yeah, matrix multiplication and inversion. And I would want us right away to tackle this question, my good students. This is the question that I would want us to do, and I'm sharing my screen. For those of you who have done CASNEB exams just the other day, you must be able to remember this question. Yeah, this is the question that we are doing here. I hope you're able to see it. So you're told XYZ Limited produces 3 products, namely A, B, and C. The company in this case here presents the profit per unit of the product. If products it produces and sells as follows: shillings 2,000, 3,000, and 4,000 for product A, B, and C, respectively, during the month of January 22. 7,000, 9,000, and 4,000 for products A, B, and C, respectively, during the month of February 2022. Then we have 1,000 and 4,000 and 2,000 for A, B, and C, respectively, during the month of March 22. The total profits in the months of January, February, and March are 17, 45, and 16 million respectively. So they want us to give them the total number of each product produced and sold using matrix algebra for 8 marks. So if you get this kind of a question, ladies and gentlemen, what will you be able to do? What shall you be able to do? If we got this kind of a question, this is what we shall be able to do, my good students. You see, already they're giving us profit per unit. Then the question is, how do I get total profit? How do I get total profit? So my total profit will be like this. You will take profit per unit. You will take profit per unit. Then you multiply this by quantity sold. Quantity sold for you to be able to get what we call total profit. For you to be able to get what we call total profit. That is what we shall be able to do. So if they want me to give them total profit, I will take profit per unit times quantity sold to be able to get my total profit. So this profit per unit has been given on a monthly basis. We have January, we have February, we have March. For which products? For products A, B, C, like that, in the form of a matrix. So they are telling us, Bwana Maurice, what they are telling us, ladies and gentlemen, here is this. They are telling us the company presents the profit per unit of the products. The profit per unit of the product it produces and sells as follows: 2,000, 3,000, and 4,000 for A, B, and C, respectively, during the month of January 22. So January, we have 2,000. January, we have 2,000. And then, ladies and gentlemen, we have 3,000 here. 3,000 here. And then still January for C, we have 4,000. That is January. So the month of January, that is what we have. Then we go to shilling 7,000, 9,000, and the 4,000 for the month of February. So for February, we have 7,000, 7,000. We have 9,000, 9,000. Then, ladies and gentlemen, we have 4,000 for February. For February. And then, ladies and gentlemen, I can see the month of March. Month of March, what do I have? 1,000, 4,000, and 2,000. 1,000, 4,000, and then 2,000. Let me know whether you good students of mine have been able to write down this matrix. Let me know whether you great students of mine have been able to write this matrix. Have you been able to write down this matrix? Yeah, thank you so much. Thank you so much. You see, quantity sold is unknown. The quantity sold here is, this is what the examiner wants me to tackle. So we shall let the quantity sold be A, B, and C, respectively. So this is the quantity sold. This is profit per unit times quantity sold should be able to give me the total profit. Total profit, ladies and gentlemen, have they given me the total profits for each of these months? Oh, yes, they have done that. So the total profit here is what here? If you look at this, the total profit in the months of January, February, and March was 17, 45, and 16. So we have here 17 million, 45 million, and then we have, ladies and gentlemen, 16 million respectively. 16 million respectively, like that. 16 million respectively, like that. So remember, we must write this like January 17 million, February 45 million, March we have 16 million, like that. Why have I written these quantities down in form of a column? It's because of how matrix multiplication does. What happens with matrix multiplication? We multiply a row with a column. A row with a column. So if you don't, you see, like now the figure of A will multiply with a A here. The figure of B will multiply with B there. The figure of C will multiply with C there. Because normally multiplication is Roman Catholic. We normally multiply using the concept of Roman Catholic. Roman Catholic. Roman Catholic. Rows multiplied by columns. Rows multiplied by columns. So to get, ladies and gentlemen, total profit, we shall take profit per unit times quantity sold to get that total profit. So can we form three equations? Let's form three equations. So these equations, ladies and gentlemen, I want to form them. And if you allow with me, if you agree with me, I should be able to simplify this by chopping 3 zeros from both sides of the equation. It's allowed to simplify this. So I can just do without these 3 zeros. Both sides of the equation, 3 zeros. So I can come and chop these 3 zeros here, like that. Although you can still work with it, but it's better you do away. So remember, it's Roman Catholic. So the first row will multiply the first column. How do we go about it? First ones multiplied, plus second ones multiplied, plus third ones multiplied. So we have this row with that. So the first one, that's 2A, plus 3B, 3B, plus 4C. Should be equal to the first number. Should be equal to 17,000. Should be equal to 17,000. Then we come to row number 2. So this row 2 multiplies this column. This row 2 multiplies this column. So we have, ladies and gentlemen, 7A. The first one's there. Plus 9 boy. Plus 9 boy. Plus, in this case here, 4 cow. 4 cow should be equal to the second value there, which is 45,000. 45,000. Then we have the last row here. So this is 1R. 1R, or just A alone, plus 4 boys. 4 boys plus 2 cows should be equal to 16,000. Should be equal to 16,000, like that. So you've been able to form, ladies and gentlemen, those three equations. Those three equations. Let me know whether you guys have been able to write up to here. So remember how we started for the students who are just joining us? We are doing a very, very simple question. The question that we are doing here needs us to get total profit. And how do we get total profit? It's profit per unit times quantity sold. So the profit per unit has been given in the form of a matrix. Quantity sold is what the examiner wants us to answer. So that is where we have our unknowns. But this quantity sold, given the years I've marked these exams, I'm aware that some students will write here A, B in form of a row. If you do that, then there will be no compatibility. Remember, we have what we call matrix compatibility. Now, ladies and gentlemen, once you have done that, you can screenshot this question. Just screenshot the question. Yeah, you can, in this case here, get this. Yeah, you can, in this case here, get the screenshot of this. I can't remember which sitting is this exactly. Yeah. All right. All right. So first of all, I want to know whether you've been able to write up to here. Have we been able to write up to here? Great. Thank you so much. Thank you so much. Thank you so much. Now, ladies and gentlemen, I would want to take this opportunity to show you what we call Cramer's rule. Cramer's rule for solving simultaneous equations. It will be very important for you to understand the Cramer's rule for solving simultaneous equations. Now, assuming we have this kind of a thing, we have here x, we don't write now. So x, for example, is 2 and y is 3. So assuming we have here x plus y is 5, and then we have here 2x plus 3y. Yeah, so that's 4. 4 plus 9. 4 plus 9, that is 13. So assuming you are given this kind of equations, and you want to get values of x and y, you can come and use elimination method. So under elimination method, if this is your first equation, second equation, you can opt to make the coefficient of x similar to what you have here. So in short, go and multiply equation 1 with the 2 throughout. So we have here equation number 1 multiplied by 2 throughout. How do we go about this? So that we will have here 2x plus 2y, everything, to be multiplied by 2, everything. So 5 times 2 is 10. And then, of course, we write equation number 2 the same way it is. 2x plus 3y equals 13. Now, because x and x are the same, we can come and eliminate. So when I eliminate this and this disappears. That is what we wanted, to eliminate x. 2y minus 3y, that gives me minus y, equals 10 minus 13, that gives me minus 3. So meaning that y and y does what here, or rather minus and minus does what here, disappears. So meaning that the answer to y is 3. So once I get that, I will be able to get the value of x from any of the two equations. So from equation 1. So from this equation 1, what do we have here? From equation number 1, we know equation 1 is here. It is x plus y. And y, we have gotten here y to be 3. X plus y, which is 3, equals 5. Therefore, x will be 5 minus 3, which gives me what figure? Which gives me 2. Yeah, I can opt, ladies and gentlemen, in this case here to use this approach. to get the value of X and Y, elimination. I can decide to use substitution. But the very easiest method, my good students, that I would want to sell to you here today is what we call Cramer's rule. Under Cramer's rule, what you're supposed to do is to come and identify what we call the base matrix. Please listen. Under Cramer's rule, first of all, you get what we call the base matrix. You give us what we call the base matrix. That is the first thing, base matrix. So this base matrix is the matrix of these coefficients. Yeah, those numbers that come before X and Y. So this base matrix, if I'm to extract it from this, before X, we have a 1. Here we have a 2. Here there is a hidden 1. Here there is a 3, like that. So once you get this base matrix, please go ahead and give me its determinant. Go ahead and give me its determinant. Is there somebody who knows what we shall do to be able to get the determinant of the base? Is there somebody who can remember the formula? How do we get determinant of a matrix? I give you the formula. It is PPD minus PSD. It is PPD minus PSD. So you take the product of the primary diagonal. Primary diagonal is normally the one that starts from the first element here. This is the primary diagonal. So this primary diagonal, come and give me its product. Remember, to get the determinant, we say it is PPD minus PSD, product of primary diagonal. The primary diagonal is 1 times 3 minus product of secondary, 2 times 1. So in this case, ladies and gentlemen, what do I have here as the determinant? What do I have here as the determinant? So determinant of the base, I'm being given by Elvis there. I'm waiting to be given these answers by many students. So determinant of the base is 1. Determinant of the base is 1. Thank you so much. Thank you so much. Under Cramer's rule, Cramer, by the way, is written like this. This is a guy whose major stuff was to cram in a class. Yeah. But at the end of the day, he came up with very, very important models that we were able to use over 100 years down the line. So cramming is not bad. You can see what cramming has given us. So under Cramer's rule, these particular figures that you have here, we normally call them replacement. So this is replacement column. That is what Cramer called them. Replacement column. Replacement column. Please listen. Please listen, because now I'm coming to the end of this. Please listen. We know what the base matrix determinant is. It is 1. Now listen. According to Cramer, Cramer said that if, for example, you want to get the value of X, you see X is column number 1. According to Cramer, if you want to get the value of X, the column of X must disappear. The column of X must disappear. Where it goes to, we don't want to go. We don't want to know. It could be going to heaven or hell. We don't want to know. What we are told by Cramer's rule is that if you want to get the column of X, the column of X, if you want to get X, the column of X disappears. In its place, we shall have the replacement. So instead of writing 1 and 2, in the place of this column, replace it with 5 and 13. If I'm getting X, then the column of Y remains. The column of Y remains. The column of Y, ladies and gentlemen, is 1 and 3. The column of Y is 1 and 3. So you know here there is an implied 1. So you write here 1 and 3 like that. And if you want to get to the value of X, so you shall get the determinant of this divided by determinant of the base. You divide by determinant of the base. These two strokes here, they simply want us to get the determinant. Determinant, ladies and gentlemen, determinant is PPD, product of primary diagonal minus what here? Product of primary diagonal minus product of secondary diagonal. Yeah, so they're giving me an answer there. They're giving me an answer already. They're giving me an answer there. So you see here, product of primary is 15 minus product of secondary. Product means you are multiplying. So 15 minus 13, that gives me 2. Divide by, are we able to remember the determinant of the base? Are we able to remember the determinant of the base? Can somebody remind me what the determinant of the base was? We found this earlier on. The determinant of the base was 1. So 2 divided by 1 gives me what figure? 2 divided by 1 gives me what figure? Are you able to see that at the end of the day, the value of x will be 2? The value of x is 2. The value of x is 2. Please listen. My good students, listen. What if I want to get y using the Cramer's way? If they want me to get y using the Cramer's way, this is how we shall get the value of y. The value of y. What you're supposed to know under Cramer's rule, there must be something that will disappear. Under Cramer's rule, there must be a column that disappears. So if I'm after y, then we must bury the column of y. If we are after getting y, the column of y will disappear. You can see the column of y is column number 2. So meaning I don't have a problem with column x. So column x is the first one. So we have here 1 and 2. Yeah. And then now we come and look at the second column is the y's column. Because y has come here, y column must be buried. In its place, we shall have the replacement. So instead of having this second column as y's column, that one has been buried, we bring the replacement. So we shall have here what we call 5 and what here? 5 and 13. 5 and 13. Which now we shall be able to come here and divide these by the determinant of the base. Divide these by the determinant of the base. So is there somebody who is able to give me the determinant? Whenever you see these two strokes over these lines, it means that we get the determinant. So determinant, it will be product of primary 13 minus product of secondary 10. So 13 minus 10, that gives me what here? That gives me 3. 3 divided by 1, that gives me 3. So y is 3. So that is what we call Cramer's rule. It's a very, very important rule. It is a very, very important rule. So I don't know whether there is somebody who has been able to understand what I've done, or is there somebody who would want me to repeat this using a different example? Yeah, remember, whenever I teach you, you're my sons, you're my daughters, you should never fear your father. Yeah, I use 3 by 3. Thank you so much. And we have it here. I use 3 by 3 and we have it here. So when we are talking of 3 by 3, it is either you use these equations that we have here, or you simply get the Cramer elements from this. So I will do this using 2 ways. 2 ways. 2 ways. I'll do this using 2 ways. Now, so first I will rub this. And then, ladies and gentlemen, we have our matrices, 2 matrices here. So we have here 2, we have here 3, we have here 4, we have here 7, we have here 9, we have here 4, we have here 1, we have here 4, we have here 2, and then, ladies and gentlemen, we happen to be having here A, B, C, and then, ladies and gentlemen, we happen to be having this here, 17,000, 45,000, 16,000. Don't forget that on top we have A, we have B, we have C. So I will show you the 2 ways, because the examiner will attack you using either method. Using either method. At times he will give you 3 questions. At times he will give you these kind of figures. Now, so ladies and gentlemen, the most important thing that I'm supposed to appreciate here is the name of this. This becomes the replacement, or just a replacing column. Great. Let's go together. So then the very first thing that I will do This matrix is what I call the base. That matrix is what I call the base. So come and give me the determinant of the base. So determinant of the base, we know the determinant of the base, ladies and gentlemen, it will be product of primary diagonal minus product of secondary diagonal. Product of primary diagonal minus product of secondary diagonal. So that is okay. So I'll use two methods again here. There are three methods actually, but I'll use two methods and then you tell me which one is easier. So it is PPD minus PSD. So remember, product of primary diagonal, slowly. Just identify the primary, the one that starts from the very first element. This one here, just slowly. Yeah, three of them. Thank you so much. Is it in Gore? Yeah, thank you so much. So the primary, this is the primary, slowly. So you come and write for us, you tell us product of primary diagonal. So we have here 2 times 9 times 2. But you see, this is a 3 by 3 matrix. If it is a 3 by 3 matrix, it has 3 primary diagonals. It has 3 primary diagonals. So these primary diagonals, you have to come and add all of them. So you come and say plus. So you see, there is one that is parallel to this, parallel. But you see, this one that is parallel, ladies and gentlemen, it has only 2 elements. It has only 2 elements. So then I will be able to come and look for the third element. So it will be 3 times 4. Is there somebody who can tell me how will I read the third element? How will I get, what is the third element? Because there must be 3 elements. There must be 3 elements. I can see this one is parallel to this primary, but has only 3. Or it has only 2 elements. I'm looking for the third element. Is there anybody who can see the third element? Third element. The third element will be normally the element which is farthest from this, or the peripheries, farthest. So you do like a right angle. Right angle, to read the third element, right angle, you go down. You go down to read the third element, farthest. So it will be 3 times 4 times 1. 3 times 4 times 1. This is the second primary. Then there is a third primary. The third primary is this one that is below. Again, it has 2 elements only. So it will be 7 times 4 times what? Somebody who is able to follow. Let me see somebody. Somebody who is able to follow. Elvis, thank you. I'll give you 2 methods. So it will be 7 times 4 right angle. You know, farthest, you can't go down. Farthest, right angle, so you're right. 7 times 4 times 4. Could you be kind enough by taking your calculator, you open brackets, you say 2 times 9 times 2 plus open brackets, 3 times 4 times 1 plus open brackets, 7 times 4 times 4. Please give me just one number. Give me just one number. Just one number. One number. Thank you, Thorn. Just one number. Yeah, you don't have to be right, remember. It's all about participation. It's all about participation. So according to Jacinta, it's 160. So Thorn, you have to, again, check your calculator. There is nothing wrong, but just check your calculator again. But they're telling me it is 160. Just check again, Thorn. If you're not able to get it, I will be able to repeat. And please, everybody must participate. When you participate, I bless you. Anybody who is participating, giving me answers, asking questions, even making the class be nice, yeah, then we shall be able to bless you. There is no student of mine who participates, who fails. Nobody. That one I can tell you. Then come and identify the secondary diagonals. Hii kitu kinajua QA inapenda mwanafunzi mwenye anapenda kuongeongea. Hata kama unaongeongea uongo. At the end of the day, you will pass. These are paper that loves those guys who like speaking. Yeah. So in this case here, secondary. So the very, very important secondary is this one here. Yeah, that's the main one. So we have here 1 times 9 times 4 plus. Great. So parallel, secondary. So this one here. But there are only 2 elements. 7 times 3 times, is there somebody who can give me the third element? 7 times 3 times something. 7 times 3 times something. 7 times 3 times 2. You're right, farthest. Here, down. Farthest, down. Yeah, no. 7, 3 farthest down. 2 like that. And then we have another secondary, which is parallel to this, which is this one, which will be 4 times 4 times the farthest. Times what figure, somebody here? 2. Thank you so much. 4 times 2. So then, ladies and gentlemen, what figure are we able to get here? So we have 1 times 9 times 4 plus 7 times 3 times 2 plus 4 times 4 times 2. What figure are we able to get here? 110. So therefore, determinant of the base, it will be 160 minus 110. It is product of the primary diagonal minus product of the secondary diagonal. So 160 minus 110, that will give us what figure? That will give us, in this case here, 50. Thank you so much. If you're writing, please write method number 2. Write method number 2. If you're writing, write there method number 2. Method 2. Right there, method number 2. Method number 2. So we have 2, 3, 4. We have 7, 9, 4. We have 1, 4, 2 like that. Right there, method number 2. Method number 2. So this method number 2, yeah, I'll be able to repeat Gatweri. Method number 2, method number 2. So this method number 2, ladies and gentlemen, and then we decide which one is better. Which one is better, and then we shall be able to talk about that Gatwiri more. So remember, the first one is supposed always to be plus, The alternating signs, The second one, negative. The third one, the alternating signs, plus. So then if you want to get the determinant, what do? So you come here and pick. So remember here, we are using this concept of hide and seek. You hide and seek. So you'll be able to come and pick this plus 2, this one here, the top number. And then now you hide that number. You hide it row-wise and column-wise. So you hide this number row-wise and column-wise. So when I hide it row-wise and column-wise, are you able to see, ladies and gentlemen, numbers that are left? If you hide it this way and this way, I'm able to see this is left. Are you able to see the numbers that are left? Because when I hide these 2, I hope we are together. It is 9442 left, 9442 left. Thank you so much. And then now you come and pick the top number, but now you pick it with a sign. So you see there is a sign on top minus. So you say minus 3 into. Now, if you are to hide these 3 numbers there, can you kindly give me the figures that are left out? Just like ile mchezo ya banya ya watoto ya hide and seek. Hide and seek. So you must hide 3 permanently. You must hide 3 permanently. You must hide 3 permanently. Let me see whether there is anybody who will be able to tell me the numbers that are left. Yeah, thank you so much. So if I was to hide these 3 column-wise and row-wise, you're right, the numbers left will be 7, 4, 1, 2. So we have here 7, 4, and then we have 1, 2. Thank you so much. You pick the third number, which is positive 4. Positive 4. And then you have, in this case here, so this number, if you are to do your hide and seek, you'll be left with this and this. You'll be left with 7, 9, 1, 4 uncovered. So we have here 7, 9, 1, 4 uncovered like that. Thank you so much. Now, ladies and gentlemen, whenever you see these 2 strokes, this is not your normal bracket. This tells us that we need to come and do what here? We need to come here and get the determinant. So determinant, I should be able to do this using my calculator. So this will be equal to 2 times determinant. We know this is 9 times 2 primary, yeah, minus 4 times 4. Like that. Yeah. And then you continue, ladies and gentlemen, good students. So the next one here will be minus 3 into, yeah. So we have here 7 times 2, 7 times 2, yeah, minus 1 times 4. Yeah, great. Plus 4 into 7 times 4, yeah, minus 1 times 9. Great. Great. So then please do me a favor. Do me a favor. Come inside the brackets first. So inside the brackets, what do we have, ladies and gentlemen? You say 9 times 2 minus 16. 9 times 2 minus 16. Give me an answer. Inside the brackets here, I'm being told that this difference is 2. Minus 3 times, how about inside here, what do we have? 14 minus 4. I'm being told the answer is 10. Plus, ladies and gentlemen, from there, we have here 4 times, how about what we have here? 7 times 4 minus 1 times 9. What do we have there? 7 times 4 minus 1 times 9. I'm being given a figure of 19. 19. So then using your calculator, can you kindly give me the final answer now? Using your calculator, please give me the final answer. So it is 2 times 2 minus 3 times 10 plus 4 times 19. Plus 4 times 19. And that is the determinant. So the determinant there is 50. Determinant is 50. And that is the same answer we got using the other method. So let's agree as a family. Let's agree as a class. Let's agree as a class. Which method do you think should we stick with? Method 2. So then Gatwiri, allow me to repeat this second method. This second method seems to be what here? Seems to be much better. The second method is better. The second method is better. So remember, under the second method, don't forget, ladies and gentlemen, by first of all putting this plus, minus, plus. It's a rule. Don't ask me where are they coming from. It's a rule. It's a rule to get determinant. And then you remember, it's about using the top row and now substituting you remember the concept of, so like now, if to get the determinant, ladies and gentlemen, we need to come and say here, 2. And then now we hide, write like this. We hide 2, row-wise and column-wise. So if I hide blup, then what am I left with? I'm left with 9, 4, 4, 2. And then you say next number is 3, but there is a minus on top of it. So minus like this. So if I hide this and this, the left out numbers are 7, 4. And then we have here, so that and that, 1 and 2. And then we have in this case here, the last one is plus 4. Plus 4. So if I hide this under that, then I'm left with 7, 9, 1, 4. 1, 4 like that. And then the very best thing that you're supposed to do, ladies and gentlemen, we only use this for 3 by 3. 2 by 2 is really easy. 2 by 2 is very easy. So in this case here now, the very best thing that you need to do is to come and use now your calculator directly. Remember, it is product of primary, diagonal, minus product of secondary, diagonal. So use your calculator directly here. So you say your product 9 times 2 minus, always remember to put the secondary in brackets so you don't confuse, especially whenever we have signs. So you say 9 times 2 minus into bracket 4 times 4. So what are we getting, ladies and gentlemen? Here it will be 2 times, please give me this answer. Give me this answer. So in this case here, 9 times 2 minus, open brackets, 4 times 4, you close. So I'm being given a figure of what here? A figure of 2. Minus 3. Minus 3, so we have here 7 times 2 minus, open brackets for the secondary. So 7 times 2 is 14 minus 4. So that gives us what figure, somebody here? I remember it was 10, right? Plus 4 times, open brackets here. So 7 times 4 minus 1 times 9, which gave us 19. So then in this case, you will be able to get that determinant as 50. Now the lady is asking a very good question. What if this number here itself was minus 3? What if this number was minus 3? So it will be minus 3, which will end up giving you positive what here? Positive 3, isn't it? So you would have written positive 3. positive 3. Is that okay, ladies and gentlemen? Is that okay? Is that okay? Is that okay? Is that okay? Yeah. So then let's get back to our question. I've wrapped my figures that I had. I've wrapped my figures that I had. Is there somebody who is able to give me those figures pretty fast? You cool students. So ABC. ABC. Are you able to give me the figures that you had here? Are you able to give me the figures that we had here? ABC. I've wrapped my board. ABC likuaje? Nakumbuka kweli? Here. 2, 3, 4. Remember we cancel the zeros, eh? We cancel the zeros, isn't it? 2, 3, 4. How about row number 2? How about row number 2? 7, 9, 4. So we have here 7, 9, 4. And then we have here 1, 4, 2. Thank you very much. 1, 4, 2. And then don't forget that we had, in this case here, A, B, C. Yeah. And then we had something here. Now this one had many thousands, had many zeros. We had something here on top. We had something here on top, 17,000. 17,000, Then we have 45,000 and 16,000. Thank you so much. 45,000, and then we have 16,000. Now, ladies and gentlemen, I want us to get the value of A. So if I want us to get the value of A out of this, the column of A will disappear. In its place, we shall be able to have this replacement. Yeah. So if they want us to give them A, the column of A disappears. So the replacement here will be 17,000, 17,000, 45,000, 45,000, 16,000, 16,000. You know, if it's A, we are getting only attack the column of A. The others remain. So we have here 3, 9, 4. We have here 4, 4, 2, like that. Divide by determinant of the base. Do you remember the determinant of the base? Determinant of the base, ilikuwa ngapi determinant of the base? 50. You divide this by the determinant of the base. Then our work, ladies and gentlemen, is to evaluate the determinant of the top number. So it's not supposed to be bracket. So give me the determinant of the top number. Abracadabra. What do we have here as the determinant of the top number? If I'm the one doing this, I will get this very, very fast. Not even a minute will pass. Because I remember, these are 3 by 3, so plus, minus, plus. So this will be 17,000. Then we are doing our abracadabra. We are hiding that 17,000. Hide and seek. So if I hide and seek, inside here we'll have 9, 4. 9, 4, 4, 2, like that. Then we say minus 3, 3, hide and seek. So I'm hiding this, I'm hiding that. I'm able to see the numbers that will be left out. 45,000, 16,000. Remember, if I'm hiding this under this, I'm left with 4, 2 there. Yeah. Plus, I have 4 there. I have 4 there. So these 4, ladies and gentlemen, the 4, ladies and gentlemen, what do we have there next? The 4, ladies and gentlemen, here, we are hiding this under that. So when you hide this under that, what do we have there? We have 45,000. Oh, have I done it correctly? Yes, 16,000. And then, of course, if it is this and that, we have 9 and 4. 9 and 4. So I'll repeat, but is there somebody who has been able to follow up to where we are? Is there somebody who has been able to follow up to where we are by any chance? Is there somebody who has been able to follow up to where we are? Great. Great. So then what we shall do, let's just finish this question, all of us, because it's the only question that I'm doing. The students who have not been able to get this nicely, we will be left behind and tackle this. We'll be left behind and tackle this. So then this one here will be 17,000 times, can somebody give me this determinant? Product of primary, so it will be 9 times 2 minus 4 times 4. Yeah, so 9 times 2 minus 4 times 4, which gives me what here? Is there somebody who's getting 2? Somebody who is getting 2 by any chance there? Yeah. And then we come and say minus 3. How about this determinant? So this will be 45,000 times 2 minus 16,000 times 4. 45,000 times 2 minus 16,000 times 4. I hope there is somebody who is following this up as I come to repeat later. So 45,000 times 2 minus 16,000 times 4. What figure are we getting there by any chance? What figure are we getting there by any chance? Yeah, please relax. I'm repeating, relax. 26,000? 26,000, all right. So we have here plus 4 into, in this case here, we have this times 4 minus 16,000 times 9. 45,000 times 4 minus 16,000 times 9. What figure do we have there? I'm being given a figure of 26,000 or 36,000. I'm waiting to get from someone else. Valentine, 36,000. Thank you so much. 36,000. Thank you so much. So then are you able to give me the final answer now? The final answer, please take this times 2 minus 3 times this plus 4 times that. Give me an answer. Give me an answer. What do we have there? 17,000 times 2 minus 3 times 26,000 plus 4 times 36,000. Give me an answer. Yeah, I'm being given there, although I need some confirmations. 100,000. I'm being given a figure of 100,000. Is it 100,000 or 1 million? Is it 100,000 or 1 million? If you use comma separators, 1 million, Use comma separators, 100,000. Please, Diana, check well. It's 100,000. And therefore, A will be equal to that 100,000 divided by 50, which will end up giving us what figure? 100,000 divided by 50, which now will end up giving us what figure? 100,000 divided by 50, which will end up giving us 2,000 units, like that. 2,000 units like that. All right. So I would want to repeat this example, but now remember, for me to repeat, I have to start from where I had shown you that 2 by 2, which was quite easy for you to see the concept. But before I go there, you will allow me to finish this question. You will allow me, in this case here, to go and get B. You'll allow me to go and get B directly using Cramer's rule. Is there somebody who thinks they can give us the value of B? Is there anybody who thinks they can easily give us the value of B? Anybody who thinks using Cramer's rule they can give us the value of B? Abracadabra. Anybody who thinks they can give us the value of B? Yes, I can get it very well. So, I know it will be something at the top divided by determinant of the base. It will be something at the top, divided by determinant of the base, which is what here? Which is 50. So I would want to see whether there is anybody who will be able to construct the numerator for B. Let me give you 1 minute. We see whether there is even a single student who will be able to construct the numerator for B. Numerator for B. Let's see. Let's see. Numerator for B. Even one student. So long as you just remember that if it's B they want me to get, then from the first matrix, the column of B must be buried. The column of B must disappear. I will not affect any other column apart from the column of boy. The column of boy is the one that will disappear. All the other columns for the first matrix called the base matrix will remain. So the column of boy is the second one. So the first and the third columns will remain. So here I will have 2, 7, 1. When I come to the column of B has to disappear. We need a replacement. And where is the replacement? It is this one. So the second column here is what we shall have being taken over by that replacement, which is 17,000, 45,000, 16,000. And then what happens in the column of C? These remains 442 like that. So I don't know whether there is now somebody who has been able to pick like what I've done to construct this column over, or rather the numerator matrix for B. Numerator matrix for B. If they want me to give them the value of B, the column of B will disappear. When they wanted me to give them the value of A, the column of A disappeared while constructing the numerator matrix. When they want me to give them the value of B, the column of B must disappear. So when the column of B disappears, it means the column of A remains, B now is there, and then we have C remains. Now from there, ladies and gentlemen, you shall be able to go ahead and give me the determinant for the numerator here. So numerator determinant. So remember, this is plus, this is minus, this is plus. So we start with the first one here, which is 2 into 2 into. So remember, if we are using 2 here, so this has to disappear, this has to disappear, this has to disappear, this has to disappear. So the leftovers will be these 4. You go to the next one, which is minus. So minus 17,000 into. So in this case here, if it is 17,000, we are 4. We have to hide it. So this row disappears. You hide it column-wise and row-wise. So this disappears. This disappears. So we are left with 7412 plus 4. So once in this case here, we have this 4, then we must hide this and that. We must hide this and that. So if we hide this and that, the leftovers are these ones. So 745,000, 745,000, 116,000. Like that. And then now you can easily go ahead and give me these figures. So therefore, this one here will be 2 times. Are you able to give me this figure, 45,000 times 2 minus 16,000 times 4? Are you able to give me that figure, ladies and gentlemen? Yeah, I will repeat. So in this case here, they are telling me it is 26,000. 26,000 minus 17,000 times determinant. So this minus that 7 times 2 minus 1 times 4. So this gives me 10. Plus, we have in this case here, the 4. So 4 times, what is this? 7 times 16,000 minus 1 times 45,000. They're giving me a figure of 67,000, right? 67,000. So then are you able to give me the final answer there as the numerator of this determinant? Determinant of the numerator, I mean. What figure are we able to get if you just follow this now? If you follow this now, what figure are we able to get? 150,000 divided by the 50, divided by the 50. So then at the end of the day, what figure shall we get? So we have there 3,000. I'm being given 3,000 units. So can I give you a minute, you try C on your own? Can I give you 1 minute, you try C on your own? Thank you so much. Let me give you 1 minute, you try C on your own. Let's see. Let's see whether you'll be able to get this C on your own pretty fast. Just try on your own. We see whether you'll be able to get it on your own. Just try. Even if you don't get it, so what? So long as you try, that is the most important thing. Just try. This must be a very, very good class. Students are very, very active. The only thing that is not very, very good is that you don't like attending these classes. You don't like attending my classes. You need to convince your colleagues that, hey, this guy is coming to assist us. This guy is coming to assist us, and then they attend many of them. Now from next semester, they shall be able to come to the senior classes. The first method is not giving the right answer. It will give us the right answer. Always. A question, please ask. It will give us the right answer. Maybe you messed up on something. It will give us the right answer, and we shall be able to try. It shall always give us the right answer. So anybody who has been able to finish this and they have been able to give us the value of C? The moment you understand that if you are after C, then the column of C must disappear. It has to be replaced. We have a replacement. So somebody called John is giving me 1,000 units. Maria, 1,000 units. Great. 1,000 units, great, great. That is the correct answer. That is the correct answer. So what I will do, I will give John and Maria 1,000 shillings. They share in between. So John, Maria, yeah, those are the first to get. So John, are you able to give me your mobile phone number? John, are you able to give me your mobile phone number? Please type it there. I always give presents to my students. Always, I shall always, in every class that I teach, I shall always give 1,000, but always, without fail. Even if you get a wrong answer, so long as you are active, so long as you are active in my class, you shall always get a present. So, and then you will be able to share this with Maria. I hope you have Maria's number. I hope you have Maria's number. Please ensure she gets, If you don't give a baby girl what belongs to her, life will not be very good. So I've added something small on top for transaction, Thank you. It's called John Paul. John Paul. No, Kennedy, the inversion method is different from the Cramer's rule. Inversion method is different from Cramer's rule. Yeah, there is one where you simply go through all that process to inverse. It's different. Cramer's rule purely uses determinants. I don't know where the method which you use during your normal class time. If you're comfortable with that method, then I shall be able to use that method. But always Cramer's rule, once you get used to it, it's perfect. It is the best. It is the best. Yeah. So Maria, now you can get something. Yeah, so we use the one, you divide and find the universe. So to me, what I would do, ladies and gentlemen, I would want to really stop it at this juncture because I know this method is a cool method. It's a better method. So if you have the other one and then you confirm that you are able to get the same answers, then that is okay. Or since I began mathematics, yeah, the universe is the most suitable. Since I began mathematics, okay. Yeah, since I began mathematics, the universe is the most suitable. Don't you think, ladies and gentlemen, if you practice a little bit, this one here can also be good? Because in the QA, students fight with what here? They fight with time. Students fight with time. Method one is simple for me. Okay, great. Somebody is saying the other method, the one where you get the third element. Very good. Me, I've just given you options. I've given you options. I've given you options. But if you want to use, in this case here, the inverse method, so remember the inversion method, this is how you go about it. The inverse method, this is how you go about it. Yeah. So inverse method, then we'll have in this case here 2a. Yeah. So in this case here, the inverse method. So what we shall do is to get the inverse of this. How do we get the inverse of this matrix? So this matrix, we could call it X or whichever. Yeah. So go ahead and give me this matrix. Yeah. So we'll have here the unknowns. The unknowns will be equal to the inverse of this base times the right-hand side values. Right-hand side values. Yeah. Yeah. So to get the inverse of the base, so first of all, give us the determinant of the base. Determinant of the base. So give us determinant of the base. So determinant of the base, I believe all of us are in agreement. It is 50, isn't it? Determinant of the base, all of us, I believe, we agree that the determinant of the base, in this case here, is 50. Is that okay? Now from there, we go ahead and find what we call the minors, isn't it? We find the minor matrices. Yeah, so determinant of the base, that is okay. So come and give us the minor. Yeah. Then we inverse. We can as well follow that method. So in this case here, come straight away and give us the minor matrices. So the smaller matrices. So the minor matrices, how do we get them? It's about hide and seek. So we have the minor matrices. So we have here the minor matrices. Minor matrices, what we are calling the M. So in this case here, come and use the hide and seek. So if they want us to give them the minor for this one here too, yeah. So you hide like that, you hide like that. Then we have in this case here 9442 like that. Great. So that's the first minor. The second minor, if they want me to give them the minor for this, you hide this and you hide that. So you hide this and you hide that. Then the leftovers will be 7412. So we have here 7412 like that. From there, ladies and gentlemen, we come for the minor for this. So the minor for this, we hide this and that. So then we're left here with 79. Then we have in this case here 14 like that. Great. So you go to the second row. So the second row, what do we have here, ladies and gentlemen? I can see these numbers here. So now I want the minor for this. So to get the minor for this, it's very easy. You hide this and you hide this. So if you hide this and this, we are left with this 3, 4. So you're left with 3, 4. and then we have 4, 2, like that. All right. Then we come to this one. So this one, you are hiding it. So we have this and this, this and this, this and this. So we are left with what? 2, 4, 1, 2, 2, 4, 1, 2. Then lastly, for the second row, we have this. So you hide this and that, hide this and that. So we have 2, 3, 1, 4, 2, 3, 1, 4, like that. We are through with that. We go to the very last one, the minus for this. So for this blah, so you're left with 3494, 3494, like that. And then we have the minor for this. So if you blah this, blah that, we are left with 2474, 2474, like that. And then now we come to the very last one here. So if you blah this and that, we're left with 2379, 2379, like that. Now from there, of course, now this minus, you have to give us this minus, ladies and gentlemen. You must come and give us what we call the determinant. That's what I'm putting like that. So go ahead and give us the determinants. So go ahead and give us the determinants of this. So those determinants will be the minus. So the minus, what do we have, ladies and gentlemen? So like the first one, it will be 9 times 2 minus 4 times 4. Are you able to give me this one here? So we have here 9 times 2, yeah, minus 4 times 4. So what figure do we have here, ladies and gentlemen? You're saying it is 2, eh? 2. From there, ladies and gentlemen, we shall be able to come here and get the second one. The second one is 7 times 2 minus 1 times 4. So 7 times 2 minus 1 times 4 gives me what figure? 10, I'm told. 10, I'm told. From there, ladies and gentlemen, we shall be able to come and take this 7 times 4 minus 1 times 9. So 7 times 4 minus 1 times 9. What figure are we getting? I'm being told 19. 19, eh? So 7 times 4, yeah, minus 1 times 9. 19. We come to this other matrix here. 3 times 2 minus 4 times 4. That gives us what figure? So minus 10. Thank you very much. From there, ladies and gentlemen, we have in this case here, from there, ladies and gentlemen, we have the second one, 2 times 2 times 2 times 2 minus 4. So that gives us 0. 0, isn't it? Right? Is that okay? 0. Thank you so much. Then you come here, 2 times 4 minus 1 times 3. 2 times 4 minus 1 times 3 gives me what figure? So this one here will give me what figure, ladies and gentlemen, here? Will give me 5, isn't it? So we have here 2 times 4 minus 1 times 3. So that gives me 5. So we come to this one here. So this one here will be 3 times 4 minus 9 times 4. Which gives me minus 24, right? So this gives me minus 24. From there, we have here 2 times 4. Yeah, 2 times 4 minus 7 times 4, which will end up giving me what figure? Minus 20. Minus 20. Then we have the last one here, 2 times 9 minus 7 times 3. Yeah, 2 times 9 minus 7 times 3 gives me what figure? Somebody there? Minus 3. Thank you so much. So there are so many ways of getting these cofactors. You can use the adjoint or use the concept of the diamond. Yeah, diamond rule. So the diamond rule, remember our diamond normally cuts through the central external elements. External only, central lakini ya katikati, diamond naenda hapa. Diamond nakuja hapa, diamond nakuja hapo, ina namna hiyo. So out of this, you'll be able to get the cofactors. So cofactors, remember, any figure that has been touched by the corner of the diamond will have its sign changing. Will have its sign changing. So then our cofactors, ladies and gentlemen, we happen to be having our cofactors. So this remains. This has been kissed by a corner of the diamond. So it becomes minus 10. This is 19. This is now positive 10. This is 0. This is negative 5. This is negative 24. This has been touched by the diamond. So in this case here, 20 positive. And then we have lastly, minus 3 like that. Now, ladies and gentlemen, after getting this, the next, remember you had gotten, is there somebody who can remind Mwalimu Oye Oye, our original matrix oye. Our original matrix. Hebu nikumbusheni row ya kwanza. Row ya kwanza ilikuwa ngapi? Row ya kwanza ile ya A, B, C. The original matrix. The original matrix oye. Original matrix oye ilikuwa na 2, 3, 4. Original matrix. Original matrix. 2, 3, 4. 2, 3, 4. Original, nataka tu original matrix 794, yeah. 794, alafu je? Ya mwisho 142. Thank you very much. Thank you very much. Thank you very much. So I hope you are able to follow up to there. I hope you are able to follow up to there. Ladies and gentlemen, after that, what do we need to do here? After that, what you need to do is something easy, is something very easy. Just a minute. After that, so we have here, yeah, so if you are not done the determinant using the other method, you can easily come and borrow this original matrix, these numbers that are here, with the cofactor matrix, the first row. If you borrow the first row of cofactors and the first row of the original matrix, you can easily get the determinant. How do we get this determinant? Very easy. So you combine. So it will be 2 times 2. So 2 times 2. Plus minus 10 times 3. Plus, in this case here, 19 times 4. So are you able to give me this answer? So determinant, you take the first one like that. You take row 1 and row 1 here. For the cofactors, you take this and this, and then you consolidate, and then you combine the numbers. Then you combine the numbers. So is there somebody who is able to confirm 50? 50. That 50 we got there. The 50 you got there. And you can also do the same, like I was trying here, with row number 2. You can decide to take row 2s. If you take this row 2 and row 2 here, you will still get that 50. It's a very easy rule. It's a very, very easy rule. Thank you so much, Austin. Very easy rule. Ladies and gentlemen, after that, getting the determinant, now come and give us, in this case here, what we call, come and give us what we call the inverse. How do we get the inverse? To get the inverse, normally what you do, you take 1 over the determinant times cofactors transposed. Cofactors transposed times cofactors transposed. So then this one here will be 1 over the determinant. The determinant, you've given me 50 times cofactors transposed. To transpose a matrix means to change rows to become columns. So like row 1 becomes column 1. So this row of cofactors goes down to give us 2, -10, and then 19. So this is row number 1, which becomes column 1. And then row number 2 becomes column 2. So we have here 10, 0, -5. So then this one here gives us -24, and then we have 20, and then we have -3. So this is our inverse. And once we've been able to get this inverse, now to get the final answers, to get the unknowns. How do we get unknowns, my good students? To get unknowns, this is how you will be able to get unknowns. So to get unknowns, you take the inverse you have gotten times the right-hand side values. Right-hand side values. So the inverse is 1 over 50 into 2 minus 10, 19. Then we have 10, 0, -5. Then we have -24, 20, -3. Is there somebody who is able to remember the right-hand side values, the ones that are the many zeros? The right-hand side values? Yeah, is there somebody who is able to remember the right-hand side values? Remember, every class I give only 1,000 bob, so I can't give any other money. I'll be overspending. Every class, once we give, that is it. So you struggle to become number 1. Yeah, so the first one was 17,000, and then we have 45,000, and then now we have what we call 16,000. Thank you so much. So then you go ahead and do your multiplications. So go ahead and do your multiplications. So the first unknown was A, remember A. So then A will be 1 over 50 into, so remember it is Roman Catholic. In multiplication, it's Roman Catholic. It's Roman Catholic. So Roman Catholic, what do we have? Row times column. So the first one will be 2 times 17,000 plus the second one, plus 10 times 45,000 plus minus 24 times 16,000. Yeah, could you kindly then get, first of all, as per Bodimus, get what's inside, and then whatever you get, you divide by 50. What answer do we have? We must get the same, not unless we missed out a sign. Not unless we missed out a sign somewhere, we must get the same answers we got using the other method. Not unless we missed a sign somewhere, we must get the same answers we got. We must get the same answers we got using the other method. Always, always. So come and take this 2 times 17,000 plus 10 times 45,000 plus minus 24 times 16,000. Say equals first. When you say equals, whatever you get, you divide by 50. Whatever you get, you divide by 50. Whatever you get, you divide by 50. Thank you very much, De La Mare and Julie. Whatever you get, you divide by 50. So I'm being told that the answer here is 2,000. The answer is 2,000. And then now you go for B. So for B, remember this constant for every one of them, 1 over 50. B is the second one. So it's again Roman Catholic. So second one, what do we have? Minus 10 times 17,000 plus 0 times 45,000 plus 20 times 16,000. Yeah. So first of all, body mass, finish what we have in brackets. Finish what we have in brackets. So we have there minus 10 times 17,000 plus, that is 0, of course, plus 20 times 16,000 equals whatever you get, you say divided by 50. Whatever you get, you say divided by 50. De La Mare is giving me a figure of 3,000. You see, dividing by 50 is the same as saying times 1 over 50, yeah? Times 1 over 50. Then now you go to C. C again, you shall do the same concept. So for C, you shall again come here and do the same concept. For C, you shall come here and do the same concept. So it will be 1 over 50 I've rubbed, but I know already the concept is at home. The concept is at home. But now there are those questions that your examiner will tell you to use Cramer's rule. There are those questions that your examiner will tell you to use Cramer's rule. If you use this inversion approach, you get totally 0. Cramer's is very, very popular. It's very, very popular. So for me, I've given you options, so it is you to choose. But whenever the examiner insists on a particular model, then automatically you should be able to do what here to use what the examiner tells you to use. Maybe the syllabus changed. During our times in high school, they used to show us both Cramer's and the inverse. Maybe the syllabus changed. I don't know, because I'm surprised Austin is telling me that he has been using only inversion method. Is there somebody who did this Cramer's rule in high school? Cramer's rule in high school? Oh, then they must have changed things. They must have changed things. They must have changed things. High school, no, okay. All right. Great, great. So then, gentlemen, I hope we've been able to give these justice. For you, the basic matrix you do, your matrices here are really, really very, very basic. They're very, very easy. If you come and see how matrices are done, yeah, For the example, the course that I did, you know, my undergraduate is in civil engineering. I'm a civil engineer by profession, an accountant by mistake. So in civil engineering, matrices can be very, very complicated. Even differentiation can be very complicated. But for your case here, I mean, passing QA is like obvious. Yours is really easy. What you need to do is a question like this, and ensure that you repeat doing this question almost immediately. Almost immediately. Yeah, seeing it for the first time. We shall overcome. With Cramer's rule, very, very easy. So if you're given any question here, if you're given a question like this, yeah, let's assume, ladies and gentlemen, we only have two variables. We have x is 10, and then we have y is maybe -5. Let's form equations. So 2x plus y. So this will be 20 minus 5. So this is 15. And then we have here, for example, 3x plus 2y. So this will be 30, 30 minus 10, 20. So if you're given these two kind of equations, and then somebody tells you, hey, use Cramer's rule, give me the value of x. Cramer's rule is the model of what here? Determinants. What I need to know under Cramer's rule is that this is a replacement, replacing column for numerator. For numerator. Denominator, I know the base. Base, the base here is 2, 1, 3, 2. This one is the base matrix, base matrix. So we start making, in this case here, x. So if they want me to get x, what do I do in the numerator? Can somebody guess here? If they want me to get x, I will have to replace the column of x. Is there somebody who can guess for us, give us the numerator matrix, the new one? If they want me to give them x, then there is some column to disappear. There will be some replacements to be done. There'll be some replacements to be done. Yeah, there'll be some replacements to be done. So if they want me to find x, so the column of x disappears. So we'll have the column, replacing column taking over. So shall I have here 15, 20. So if they want me to give them x, then it is only the column of x that can be affected. Y will remain. So y remaining means 1, 2, like that. Divided by the determinant of the base. The base here is 2, 1, 3, 2. So determinants like that. Determinants. Great. Now from there, ladies and gentlemen, you'll be able to go ahead and give me the determinants here now. You know, determinant is product of primary diagonal minus product of secondary diagonal. So like now, this one here will be 15 times 2, 30, 30 minus 20. That gives me 10. That gives me 10. Because it's 30 minus 20, 10. All over this one here, 2 times 2 is 4. 4 minus 3, 1. So meaning that the value of x is what here? Is 10. So as you continue going to the inversion, already I've done x. Now I'll be able to go to y. So how do I get y? Very, very easy, numerator. If they want me to find the value of y, it is the column of y that will disappear. If they want me to find the value of y, it is the column of y that will disappear. And then remember that y is column number 2. So column number 1 remains. So we have here 2, 3. And then the column of y is disappearing. So we have here 15, 20 over this denominator. The denominator doesn't change. 3, 2, like that. So then you go ahead and do your multiplications. So this is 40. 40 minus 45. That's minus 15. All over, this is 4. So this is 1. So the answer is minus 15. Like that. So is this now something you think you can easily, revise and do it? If the examiner insists on Cramer's rule, is it something you think you can now try throwing the ball towards it? Or if the examiner tells you Cramer's rule, you will still insist on inverse? I'm waiting to hear from you. Is it something you guys think you can work with? Wait, they are not talking. They are not talking. They are not talking. Okay, it is -5, not -15. Okay, let's see. They're saying it's -5. Okay, yeah. 2 times 20 is 40. 40 minus 15 times 3, 45. Yeah, it's -5. Thank you very much for that. -5. Yeah, so the final answer is -5. So then tomorrow we shall be able to look at probabilities, but I hope I will be able to get enough quorum. Enough quorum. So, and for your revision, for this one, if the examiner can either bring this input output or he gives us a Markov. Markov analysis is never a tough one. So Markov you should be able to read on your own. So when I come tomorrow, my role will be to take you through this probability, the binomial distributions. Yeah, very good distributions here. Great. So see you tomorrow. Thank you so much. Be blessed.